Hey guys, GCSE STEM here. In today's video, we're going to be covering the topic of elastic potential energy. And by the end of this video, you should both know the formula for elastic potential energy and the definition for it. When a spring is stretched or compressed, work is done on the spring which results in a transfer of energy to the spring's elastic potential energy store. Elastic potential energy is defined as the energy stored in an elastic object when work is done on that object. This can mean that any object that can change shape by stretching, bending, or compressing. For example, springs and rubber bands can store elastic energy. Over here, we can see the original height of the spring. We can see that when a force or a load is added onto the spring, a force is exerted downwards, causing the spring to stretch, and it is the stretch known as the extension. The formula for elastic potential energy is E, which is the elastic potential energy in joules, equals a half multiplied by K multiplied by E squared, where K is the spring constant in newtons per meter, denoted by the units Nm, and extension is the extension in meters. So here's a practice question. It says, a mass is attached to the bottom of a hanging spring with a spring constant of 300 Newton meters. The spring stretches from a length of 15 centimeters to 20 centimeters. Calculate the elastic potential energy stored by the stretched spring. So using the formula from the previous slides, pause the video and have a go. Well, first we would list the unknown quantities. Sorry, I meant the known quantities. So that would be the spring constant is equal to 300 Newton meters. The extension is 5 centimeters. But with the centimeters, we'd have to convert that back to meters, as that's the units of extension. So we do 5 divided by 100, and that would give us 0.05. Then we would write out the elastic potential energy equation, which is E equals a half KE squared. And then we plug in our values, which would be half multiplied by 300 multiplied by 0.05 squared, and you would get 0.75 joules. So I hope by the end of this video you should be able to calculate the elastic potential energy of an object and the definition of elastic potential energy. That was GCSE STEM. If you've enjoyed this video, please give it a like, comment and subscribe, and I'll see you next time.